Yeah, thanks, Jen. Will do.
Thank you.
Okay, my name is Tim McLaughlin. I'm an associate professor in the Department of Visualization, and thanks, Jen, for putting this workshop together. It's great to get everybody together and hear these ideas, and I appreciate the opportunity to share some things I'm interested in with everyone here. So stated cleanly, I'm interested in collaborative environments, so digital environments where we can come together as creative problem solvers. And I'm also interested in visual fidelity in the sense of making aesthetic choices that are based upon a particular goal, such as learning outcomes or task objectives. So I want to start with, I guess, a test, if you will, not to ask you to raise your hands or sound off, but just to think about what you see when you see this image sequence. It should communicate something to you fairly clearly, I hope.
A walking dog? Oh.
Yeah, close. So certainly a quadruped and a carnivorous quadruped. A dog could be carnivorous, right? So there's information that is embedded in the movement of those dots. You know, you could say, well, I'm seeing black dots on a white screen, and that would be correct as well. But you're also seeing something that is coordinated movement, and it's a very simplified presentation of a complex behavior or action. How about this one? So think about that one for a minute. Should appear significantly.
Two persons are dancing, and out and a kid.
Yeah, could have been. I'd like to say there were no wrong answers, but that was wrong, the wrong answer. So here we have a gorilla walking, and in the same way, what we have is a collection of points. The points have a coordinated movement together. These are actually hand tracked, you know, frame by frame, 30 frames a second. Just 2D tracking, so no 3D tracking, tracked by hand. But what that tracking is data, and the data is coming toward us, forward to us, and communicating something specific about the identity of the actor, right? This is part of my work when I was in industry prior to coming to Texas A&M University, where our job was to take complex visual art and turn it into computer graphics techniques so that we could communicate something important. What was important was the story that the director wanted to tell. And the quote on the top of this slide is from George Lucas. He said, basically, if a ship on a stick tells a story, then use the ship on a stick. So he didn't care about how complex our technology was. What he cared about was telling a story. What he cared about was communication. So the ship on a stick is, if I need to tell the story of a starship flying through space, and the easiest way and best way to tell that story is to put the model of the ship on the end of a stick and have a stagehand run in front of the camera with it, and that tells the story, then that's the technology to use. Now, all of us who were technologists, you know, we wanted to use the most interesting, high-tech, complex way of doing it, but we stayed true to the vision, which is, okay, what is the simplest, most elegant way to communicate really complex behaviors? That was the choice that we were always trying to make. The industry, the visual effects industry, has moved in a direction that is in a convergence with a lot of other industries now, where we have real-time, high fidelity computer graphics coming into an augmented space. So we have the capacity to put a lot of people into the same space who are key decision makers. We have the capacity to vary the visual fidelity of what we're trying to do up and down the range. We can achieve very high fidelity actors, such as the metahumans from Epic Games. We can integrate photorealistic environments with live actors. All this is coming together in what is known as virtual production or in-camera effects and XR, extended reality. This is very appealing to me because as an educator, I'm interested in educating students who are interested in visual effects and animation, but I'm also interested in students, fellow faculty, others who want to use this technology for the purpose of lots of different disciplines and fields, including architecture, engineering, construction, manufacturing, product design, and then digital twins comes into this. So you can think of a lot of these areas as having a digital twin component to them that is important. So I love the fact that these computer graphics techniques that used to be relegated toward this high-end theatrical performance of visualization is now into so many different fields and is important to these fields for communicating what is the essence of their story or their data that they need to tell. So the collaborative side of it is that when I entered into the visual effects industry, it was right at this changeover. You know, Jurassic Park had just come out, Toy Story was not out yet, but there was so much going on in the visual effects industry that was live action on the stage, and that was transitioning to this digital environment. When it was live action on the stage, all of the key creatives were in the same space at the same time, looking at the same problem set. So they could solve problems in real time, they could make important decisions in real time. When we moved to digital workstations, then we lost that, and we all went into our little workspaces, worked on our graphics workstations, and then we would get back together daily, you know, typically dailies or a couple of times a day, and talk about our decisions, and then go back again. And we lost that free flow exchange of ideas. Today, with various reasons, we are now able to get back together in real time and look at the problem set together. We could be on different continents, we could be in completely different spaces, but we can do so now. And I think that's really important across a range of the different disciplines that I just discussed. One of the key players in this development is NVIDIA's Omniverse. What Omniverse is providing, and there are competitors on the horizon for sure, but Omniverse is ahead of the curve in that they are providing this 3D workspace for collaborations that require a high level of visual fidelity. We can also run high precision simulation. We can work in real time with one another, making exchanges of information based upon our own tool set because there is a standardized data format, the USD format developed by Pixar. So we can work in real time, we can separate ourselves and do our own work back in our own space and then come back together as needed. And I think that's a wonderful and exciting solution that I hope will be adopted on this campus in multiple ways. So imagine a team of us get together and we're looking at some of the projects that you all have presented today or will be presented later, and we can work collaboratively in the same workspace as we deal with very important issues. So I want to play on the next slide. Well, got one more slide coming up. So this NVIDIA Omniverse it was launched primarily for entertainment, but that was just their way of, I think, marketing wise, of making a splash with it. They have it, NVIDIA has it geared toward several different disciplines, and they are customizing what Omniverse can do based upon these disciplines. And so I think there's a lot of an exciting future going on with Omniverse. So here's a little bit of a, let's see, yeah, a little bit of a commercial, if you will, about it. Oops, sorry. Hold on. That wasn't supposed to work that way. Are you still seeing my screen?
Yes,
All right.
but you're not sharing your slides yet.
Yeah, there we go.
Okay.
Let me try again to switch slides. There we go. Okay. All right. So what I like about that commercial from Omniverse is that it is showing a range of different stylistically visual choices that are being made. And those are purposefully driven. And if you think about things that we want to do together, we have to think about what it is we're trying to communicate. And this is where my strongest interest comes in with digital twins, which is we're overloaded potentially with information. And we need to make sure that we pull from that information the right elements that we need, or perhaps a hierarchy of elements that we need viewers to see. So it could be that speed of recognition is important. It could be that we need certain features identified in a particular order. So we have to make these choices, and I think we have to do so in a very deliberate way in order to be most effective with the visual representation of our digital twins. And it's not just an abstraction of features like from an LOD point of view. So think about forms, movement, lighting, materials, the way we compose our images. The image on the top is a it's a computer graphics image, very much on a photoreal bent. The image on the bottom is a stylistically abstracted representation of a space, of a classroom. Now, if you think about what's happening is we're taking form and lighting and movement and composition and making choices about simplification or abstraction. If you are creating a digital twin of a city, and this is from work we've been talking about with Alan Liu at the Val G. Himmons Simulation Center, is what if we need people to recognize that they are in a particular city? What are the key identifying features of that city so that recognition of their environment happens quickly and immediately? So we go back to what I showed you earlier. What are the key identifying features that communicate the identity of that place? Can we pull those through and make sure that they understand that they're in Houston, not Los Angeles, and they're in Miami and not Minneapolis? Right. Those are some questions I would love to explore with everyone. And I appreciate the opportunity to present this today, and I'm open for questions.
Great, team. Thank you so much.